Well, hey, who's ready for another trig video? I know I am. So now we're going to look at some ideas that I kind of built upon the previous video of kind of like estimating trig values. But now we're going to talk more about getting exact trig values. And so some of the things we're going to rely on here, aside from the concepts of the previous video, is we're definitely going to take advantage of some knowledge we have about the two special right triangles, the isosceles right triangle and the 30, 60, 90 right triangle, and knowing kind of how the sides relate in those two triangles. We'll also be dealing with angles that happen to land right on an axis like 90 or 180 or 270. So here we go. Let's take this first one, cosine of negative 150 and the cosecant of 150. And now we're shooting for exact answers this time, not just estimates, but exact answers. So I've got my paper once again. I'm going to go ahead and scale it. Remember, about halfway is about 30. That'd be about 60, 90, 120, and 150. So we'll first of all draw in the rotation of negative 150. Remember, negative rotation goes clockwise. I'm just going to kind of darken this in. And by the way, I've left a template for this type of graph paper, the circle paper with the grid inside of it attached to the back of assignment 10. So that way you can print out copies of this if you'd like to use it on your assignment and on your test. So I've got a rotation of negative 150 degrees, and we then draw the reference triangle. Again, we go to the x-axis and to the origin. And now we're hoping that what we have is a special triangle. Because if it's a special triangle, we know a lot about the lengths of the legs and the hypotenuse. So if I rotate 150, that means there's another 30-degree arc right here. And so the angle at the center has got to be 30 degrees. And this is 60 and 90. And so we have that special right triangle that we were looking for. And again, the most important relationship is the 1 to 2 relationship, the short leg being a 1, and then the hypotenuse or radius being a 2. In a 30, 60, 90 triangle, the short leg is always half the hypotenuse. And you could then, if you either remember what this side is, or you could think, well, 2 squared is 4, take away 1 squared is 1, 4 take away 1 is 3, so this has to be a root 3. So now the only other thing we have to do is remember about the positive and negative stuff. So the legs can take on negative value. This leg is going to the left, so we'll call that a negative root 3. This leg is going down, so we'll call it a negative 1. And remember, the hypotenuse kind of stays neutral in the whole conversation. It's only the legs that'll take on negative value. Keep the hypotenuse neutral in all cases. So now we can start to decide, okay, what is the cosine of negative 150? So with respect to the center, we always do these things with respect to the center, the adjacent over the hypotenuse, or if you will, the horizontal displacement over the radius. So negative root 3 over 2, negative root 3. That's what I would guess that the cosine of negative 150 is equivalent to. And we can check that on our calculator. Some calculators will give you answers in exact form, others will give you decimals. So let's see. So if I go cosine negative 150, I get negative 866. Well, let's check and see if that's the same as root 3. So negative root 3. Then I want to divide that by 2, and let's see what that's, negative 866. So I'm feeling like, okay, I definitely got it. And again, some calculators will display answers in the radical form, which is kind of a nice feature. Maybe this one does, but I just haven't figured out how to set that up. Maybe you can. So now let's go to the next one, which is the cosecant of 150. Now keep in mind, cosecant, this is the reciprocal of sine. Okay? Cosecant is the reciprocal of sine. And so I want to think about what the sine ratio is. Well, sine would be the opposite over the hypotenuse, opposite over hypotenuse. So -1/2, that would be the sine ratio, but I want the reciprocal in this case. So if I took this and flipped it over, it'd be -2 to 1. So I think the cosecant of the cosecant of 150, that should be -150, my apologies, is -2. And so let's see if I can do that on my calculator. I'll do 1 divided by the sine of -150. And I do get -2, so I'm feeling pretty confident in my work so far. So that's the first one using, in this case, a 30, 60, 90 triangle. Now let's take another problem, a little different, is this time we don't know the rotation, but we do know that the secant is equal to √2. And one thing is when you see something like √2 or √3, those are kind of tip-offs as to what kind of triangle you're probably dealing with. So I see something like a √2 to 1 relation. I'm thinking, okay, what I'm looking for may have something to do with a 45, 45, 90 triangle. So I start kind of thinking about 45 degrees. And so 45 degrees would be right about here. And let's kind of see if this makes any sense. Now, if 45 is right, then I have a leg of 1, and a hypotenuse of √2. Now secant is the reciprocal of cosine. So if I want the secant to be √2 to 1, that means I want the cosine to be 1 over √2. Well, I think we have it right here. This is 1 over √2. So I'm beginning, I think we're in the perfect spot. So we were pretty fortunate. We got it on the very first time, is right in here. We've got the 1, 1, √2, meaning I'm pretty sure this is 45 degrees. A 45 degree angle would have a secant ratio of √2 to 1. And let's go ahead and check that. So I'm going to do secant, so 1 divided by cosine of 45 degrees works out to be 1.414. Now I have to see if that's the same as √2. So second √2, it is 1.414. Now another way you can do this, which is a little involved in the calculator, is you could turn this into a cosine problem and say, well, if secant's √2 to 1, that means that cosine is 1 over √2, meaning you could do an inverse cosine, so second cosine, and then I would do this 1 over √2, 1 divided by second √2. So what I'm asking is, what angle has a cosine ratio of 1 over √2? And that's exactly what this is saying. What angle has a cosine ratio of 1 over √2? We hit enter, and it says 45 degrees, just like I thought it was earlier. So now I'm feeling even more confident. However, we saw in the previous video that these problems often have more than one answer. 45 degrees is definitely one rotation that works here, but might there be another rotation? Might there be another place where we could keep that adjacent leg of 1 and keep a hypotenuse of √2? So let me start moving around. So if I go over to here and I think about, could it be over here? Well, no, because this is a -1 over √2, so that's no good. So I'll go down to the next one, halfway into the next quadrant, thinking here, and once again I'm disappointed. This is -1 over √2, so that's no good. So finally, I'll get myself down here, and I'll think a bit about this. I've got, okay, there's my 1, and then root 2. Again, the hypotenuse stays neutral here. So I think that would be the other location right here. Now you could represent this one of two ways. You could call this negative 45 degrees. Clear a little room here. You could use negative 45. Or you could come at it the other way of saying, all right, well, here's 90, 180, 270 plus 45, 315 degrees. Two different rotations to get you that terminate in the same exact spot. So there would be the second answer. I could either say here, well, here are my two answers, or here are my two answers for the angle. And again, the key is seeing that number and realizing what kind of triangle might be involved. Okay, let's move on to one that's a little different, one where you actually don't have a triangle. And this is when you have rotations of 90 or 180 or 270 that you really don't see the triangle. You have to kind of imagine a special triangle. So let's take the rotation negative 90. So negative 90 degrees takes us right there. There's negative 90 degrees. And so now the triangle, this is where it gets a little interesting. You draw to the x-axis, and then you draw to the origin. It's the same place that you're drawing. And you have this kind of squished triangle. Okay? So what I'm going to do is I'm going to draw a triangle that's not quite to 90, just so I can kind of see it a little better, like maybe at 80-something degrees. Okay? Right in here, and here, and here. And realize, okay, as I rotate over, these two pieces end up sitting one on top of the other. The vertical, or the opposite, and the hypotenuse in this position are sitting right on top of one another, and the adjacent, okay, has pretty much gone down to a 0. So what I have is I've got 0 for the adjacent. I've got a negative, okay, legs can be negative, so I'm going to call that negative 1. And I'm going to leave the hypotenuse, I'm going to call that 1. But again, I'm going to keep it neutral because it's the hypotenuse. So in this position, what we have here is we have an opposite equal to negative 1. We've got a hypotenuse of 1. And we have an adjacent or horizontal of 0. And now that we have those numbers, we can use them in answering these questions up here. So tangent is opposite over adjacent. So tangent of negative 90, opposite of negative 1 over adjacent 0. And that's an undefined value. You can't divide 0 into negative 1 and get any type of numerical answer. So tangent of negative 90 degrees is undefined according to my work. Let's see if the calculator agrees. So I'm going to go tangent of negative 90. And yeah, it's an error. So there's an error in the domain. In other words, when I plug in negative 90, I don't get a well-defined answer. So this undefined kind of makes sense. So now cotangent, okay, cotangent is the reciprocal of tangent. So I would simply take these numbers and take the reciprocal. 0 over negative 1, and this is equal to 0. So the cotangent of negative 90 would be 0. Now, checking this on a calculator can get a little interesting. I'm going to go ahead and do clear all that. 1 divided by 1 divided by tan negative 90. We'll see what it says. And once again, it says an error. Okay? So but the reason why it says an error in this case is because in terms of processing, it's going to process tan of negative 90, which is undefined, and at that point, it stops the calculation. The calculator doesn't know how to really process undefined value. So this is going to mislead the user to thinking, oh, the cotangent of negative 90 doesn't exist, it's undefined. Well, it does exist, and it's equal to the value of 0. So again, that's why knowing how to kind of visualize all this stuff is very important, because there are times when a calculator will not be able to handle the calculation for you. Let's take one more example. Let's say the sine of a rotation is 0. So now sine is, again, the opposite over the hypotenuse. And if I want it to be 0, I need the numerator to be a 0. So I need to think about where the opposite, where the vertical is 0. And with a little bit of thought, you realize, okay, so wait a minute, right here. At 0 degrees, okay, I have no height. So I think 0 degrees will work in this problem. At 0 degrees, I believe the sine ratio is 0. So I'm going to go ahead and check that. So sine of 0 degrees, yes, is 0. Or you can do it the other way and say, well, what's the inverse sine of 0 would equal 0 degrees. So I'm pretty happy with that first answer. But again, just like before, sometimes there's more than one answer. Where else is the height, or the opposite, equal to 0? Let's see. Well, here the height is 1, so that's no good. How about over here? Yes, right over here, okay? Right over here, again, you have a height of 0. And so how do we get there? Well, that's a rotation of 180 degrees. At 180 degrees, the sine ratio will be a 0. And let's see if we can confirm that. So sine of 180 does equal 0. You could actually push it a little further and say, well, wouldn't 360 degrees work as well? So let's see. Let's do sine 360. Why, yes, it does. 0. Okay. So again, remember, there's an infinite number of solutions one could find to this problem, and these are just three of them: 0, 180, and 360. So that wraps it up for this video. Hopefully, gives you a few more ideas for visualizing trig relationships.